one concept of WheatStone bridge, okay, where four resistances R1, R2, R3 and R4 are the resistances which are connected across all the four branches of an electrical circuit, and the arrangement will be looking like this, okay. So in the WheatStone bridge, what is the principle which is followed? Let us see, okay. In this bridge, four resistances and one galvanometer is used, okay. The WheatStone bridge is a balanced bridge where when a current I is passing through the circuit, okay, and let's say in this branch I1 current is passing and in this branch I2 current is passing, right? Then we can say that when there will be no current through the galvanometer, then we will be saying the bridge is balanced and the ratio of R1 by R2 will be equal to R3 by R4. So this WheatStone bridge is used when we are knowing two values, let's say R1, R2. Out of the four resistances, we are knowing two of the values and one of the value is not known to us. Then keeping this as a rheostat, that means as a variable resistance, we just adjust the values to calculate the value of the unknown resistances, okay. This is used in the calculation of some electrical wire or the resistances which is not known to you, okay. So this is also known as the balanced bridge, right? So when I current is, this is a battery, through this when I current is flowing, then I is divided into two parts, that is it's going into one branch as I1 and into the another branch as I2, and I1 and I2 both the currents will be added to give you the main current I, right? Now let's say if this is point A, right, this is point B, this is point B, this is point C, and this is point D, right? These are the four junctions A, B, C and D, right? Then you can see the potential difference which will be generating across R1 is VB minus VA, right? So VB minus VA, that means voltage at this point and voltage at this point. When this will be subtracted, this will give you the potential difference across this branch, right? So VB minus VA will be the potential difference, and by Ohm's law we know that this voltage, the potential, will be equal to I1 into R1, because I1 is the current which is coming into this branch, right? So I1 into R1. Similarly, when this bridge is balanced as per the condition of the WheatStone bridge, when the bridge is balanced, no current will be flowing through this, there will be no current, okay. So this arrangement is like this: when the no current will be flowing through the galvanometer, then we can say that this bridge is balanced, and this current I1 will pass as it is over here, I1, right? And no branches of this, no value of the current will be passing through this G, this galvanometer, because you will be not showing any deflection. This galvanometer will be acting as an ammeter over here. It measures the current. When the needle of the galvanometer is 0, that means when we can say that this bridge is balanced and no current is passing through it, then we can say that this I1 which is passing through R1, it directly passes from junction B and going all I1 current is passing through the R2. Similarly, this I2 current which is passing through R3 will be not going through this galvanometer, this branch, and it is directly passing from here to here, right? And here we have I2 through R4, right? So this is the condition which is generated into the WheatStone bridge. So the potential difference for B to A, VB minus BA is I1 into R1, right? Similarly, this will be equal, this will be equal to the potential difference across this one. So let us see, because the current is same. So VC minus VB will be potential difference across this branch, right? And this is equal to the same current into R2, isn't it? Right? Now, since I1 is the same variable, right? We just divide it, LHS and RHS. Then we will get VB minus VA by VC minus VB, as I1 will be cancelled out. This will be equal to R1 by R2. This is one of the relation which is derived, right? Now, similarly, for I2 current which is coming into the lower branch and passing through R3, for I2 current, right? What we can say, the potential difference across across this branch, right? That is VD minus VA is equal to I2 into R3, right? I2 is this current and R3 is this resistance, right? And the same current, as I said, this is passing through R4 because no current is passing through this galvanometer, right? The deflection in the galvanometer is 0. Then only this bridge is said to be balanced, right? Now, in this case, the current which is passing through this R4 will be the same I2 which is coming through R3. So, the potential difference, that is here, is VC minus VD. So, VC minus VD is equal to I2 into R4. Similarly, as we did for the above branch, we will do for this and divide LHS and RHS. Then I2 and I2 will be cancelled out, right? Then we will get the relation VD minus VA divided by VC minus VD as R3 by R4. Now, as we have considered, the current through this galvanometer should be 0. So this will be 0, then we can say that VB is equal to VD. VB is equal to VD. Why? These are at the same potential. The voltage at point B should be equal to voltage at point D. Then in this condition only no current will be flowing through this galvanometer, right? Because when there will be potential difference, then only some current will be flowing through any 2 points, right? So here VB and here VD, and if these both the potentials are equal, no current is allowed to flow from here, because from higher potential to the lower potential current is always flowing. Okay, the current is always flowing from the higher potential to the lower potential. So here there will be no current, right? So in this condition, since VB equal to VD, right, what we will do, we'll just put up the value over here. Okay, so what we can see, this will be equal to VD minus VA. Since VB equal to VD, so in place of VB we can write VD. So R1 by R2 equal to VD minus VA by VC minus VB, right? So VC minus VB, in place of VB just write V, in place of VB just write VD, right? Because the potential at B is equal to potential at D. Here we can say VB is equal to VD, right? So here we can see this is equal to, this is the new value of R1 by R2, and you can see here VD minus VA by VC minus VD is also the value of R3 by R4. Here you can see, So from the equation 1 and this equation 2, right? We can, this is equation 1, this is equation 2. We can say R1 by R2 equal to R3 by R4. From 1 and 2, we can say, just check the potential values, the ratio. From 1 and 2, on comparison, we can say R1 by R2, which is the RHS of this equation 1, is equal to R3 by R4, which is the RHS of equation 2, and both the LHS are equal. So this is equal to R3 by R4. Students, we will be using the principle of Wheatstone bridge in calculating the resistances of some unknown resistance. Okay, so if there are two values, let's say R1 by R2 equal to R3 by R4, and one of the value is not known to you, this is not known to you, okay, and other three values are known to you, then you are able to calculate it by doing the simple arithmetic calculation. Okay, let us solve an example first. Okay, so in the example, what we will be doing, we will be solving one question. So in this question, a bridge is given to you. In this example, we are taking a bridge, okay, in which the two resistances here is 10 ohm, which was earlier our R1, and thus here the resistance into another branch is 20 ohm, right? And if here in the fourth branch is 40 ohm, right? And this is unknown resistance R to you, right? And this is the resistance of the galvanometer, let's say 50 ohm. So this is the electrical circuit which is presented to you into this numerical, right? And it's given that find the value of R when there is no current through this 50 ohm resistance. Since there is no current through this 50 ohm resistance, and yeah, definitely how current will be flowing? Current will be flowing when definitely there will be a voltage source. Okay, so let's say this is the voltage source, right? Now, since the current is flowing through it, current is flowing through it, right? We can say that it's given that no current through 50 ohm resistor. This is the condition which is given into your numerical, right? That means if no current is flowing through this 50 ohm resistance, that means this bridge is balanced. This bridge is balanced. We can say this bridge is balanced, and this will be acting as a Wheatstone bridge, right? In this case, we will be using the relation R1 by R2 equal to R3 by R4. Why? Because if the part of current which is flowing through this branch, the same current, will be flowing through this branch, because the current through 50 ohm is 0, right? So if I1 is here, just changing my pen, okay, if here we have I1, right, then same current I1 is flowing through this, and here through R, if its current is I2, right, then same current I2 is flowing through 40 ohm, right? And let's say if this is the I, right, we need not to calculate the values of I1 and I2, but simply see how it is working. So in this case, we need to, in this question, we need to find the value of R is what, right? So here by Wheatstone bridge principles, by principle of Wheatstone bridge, what happens? R1 by R2 equal to R3 by R4, where this is R1, this is R2, this is R3, and this is R4, right? So R1 by R2 is equal to R3 by R4, right? and R1 is given to you as 10 ohm and R2 is 20 ohm and R3 is this one which is not known to you. So this will be the variable R. Just put it as it is, divided by R4 which is 40, right? I think this is clear to you. This is 40 ohm. Now the on just simple arithmetic calculation we will find the value of R equal to 40 ohm divided by 2. So the value of the unknown resistance is calculated, which is equal to 20 ohm. This is the answer, right? So 20 ohm is the value of this unknown resistance. And the question was that no current, the condition given into your question is that no current was flowing through this 50 ohm. So I hope you liked the today's session. Just if you find it useful, you can like it. Thank you so much. Bye bye. I will come up with the next topic. You can go through my playlist of electricity and through my channel, and there are multiple playlists of mathematics and physics. You can go through the channel and the multiple playlist and various selected questions. You will find it definitely useful. Okay. If you find it useful anywhere, you can just like. Thank you so much for watching. Bye bye.